Alright, welcome to video number 7 in the series. Why do I have these dice indicating the number 7? It's because there are some properties of dice you may not know about that involve the number 7. For example, when you roll 2 dice, the most common roll that you can get is a 7. You've heard of lucky number 7. That's part of the reason why. You roll 2 dice, the most common roll you get is a 7. Something else you may not know, if you take any particular 6-sided die and you look at one of the faces and the opposite face, they always add up to 7. Alright, so if you've got the number 1, guess what's on the other side? It's a 6. And if you've got the number 4 on the other side, is a 3, it always adds up to 7. So a little bit of info for you there. Kind of running out of athletic equipment. Had, tennis balls, racquetballs, basketballs, footballs. I've kind of run out. I thought I wanted to get a dodgeball, but I couldn't find a dodgeball. Luckily, I did find a wrench. So if you're a movie fan, you'll get that. Today we're going to be talking about simplifying radicals. It's a new concept, at least related, not really related to the other videos that we've done. But we're kind of moving forward, and this is a skill that hopefully you've seen somewhere along the way, and hopefully when we do it, it'll jog your memory. Just really important to take a day and make sure that everyone can simplify radicals, because as we move forward, looking at different kinds of numbers here in the next couple weeks, it's going to be really important that we can simplify radicals. So I've started with a nice friendly example, the square root of 25, which obviously you know is 5. It's nice and easy. Now, but if I ask you what the square root of 12 was, what I would expect most of you would do is go to your calculator, you type in the square root of 12, and whatever comes up, and I think it's something like 1, and there's more stuff. After that, you'd say that's my answer, that's the square root of 12. Well, it's not really accurate. It's awfully close, but it's not mathematically accurate for a couple reasons. One, I put this ... here. That ... indicates you've got some kind of repeating pattern. And as you can tell, as that decimal fills your calculator screen, that's not a constant pattern. It seems to be kind of random numbers. So that's not really accurate to say. The other thing is I can't say that these two really are equal to each other. They're close, but if I had a bigger calculator, or I had a computer, let's say, and I could see more decimal places, that decimal would continue on. So really, I can't say these two things are the same. I could use this instead. If you've seen that means approximately equal to. They're about the same. They're awfully close to one another, but they're not the same number. That's because the square root of 12 is a type of number that we call irrational. All right? An irrational number, if you look up irrational number in a glossary, an index, or a math dictionary, what you'll find, the definition will say an irrational number has a decimal that is non-terminating and non-repeating. The decimal is non-terminating and non-repeating. In other words, that decimal doesn't stop and it doesn't have a repeating pattern. So, if I have something like a half, well, that's just 0.5, the end. That's a rational number because that decimal terminates. It stops somewhere. If I have a number like 1/3, which would be 0.333, and that 3 is repeating forever, that would be rational, right? That's a decimal that's repeating. But something like the square root of 12, it goes on forever and there is no repeating pattern to it. So we call an irrational number. We're going to be looking at a lot of different irrational numbers here in the next couple of sections. Right? So how then do we answer what is the square root of 12? How can I simplify that square root of 12? All right? And in order to simplify a radical, we break the number under the square root, under the radical. It's called the radicand, those of you like math vocabulary. The number that's under the radical, we break that down as much as we can using a factor tree. All right, so I think about, well, how can I break down 12 into factors? Well, one way would be to say 2 times 6 is 12. You continue breaking down that number until you can't break it down anymore, until we get all prime numbers. So 2 doesn't break down anymore. 1 times 2, you don't have to write the ones, just 2's prime, we can stop there. Now we can break down 6 into 2 times 3. And now at the end of our tree, we have a 2, a 2, and a 3. 2 times 3 would give us the 12. Here's how that breakdown helps us simplify this square root. In order to simplify this square root, we're looking to bring things outside of the square root. What we bring outside the square root is any number that shows up twice at the end of our factor tree. So in this case, I have a pair of 2's. Right? That pair of 2's means a single 2 comes out of the radical. It comes out of the square root. So a 2 will come out. Now we also have a 3. There isn't a pair of 3's. There's just one leftover 3. That leftover 3 stays inside of our square root, or inside of our radical. Like that. And that is what our answer looks like. The square root of 12 can be simplified. It can be broken down into 2 times the square root of 3. Or you'll hear it's 2 radical 3. They mean the same thing. Now if you put 2 times the square root of 3 into your calculator, you get that exact same decimal that you got for the square root of 12. They're equal to one another. This is considered a more simplified way to do that. You know, just like you wouldn't leave a fraction as 5 over 10, you'd reduce it down to a half. Same idea here. You wouldn't leave a square root as the square root of 12. You would break it down into 2 times the square root of 3. Now, it's possible that you broke down this square root of 12 a different way, and I'll show you that real quick. So well, I thought of the square root of 12 as being 3 times 4. And that's fine, because what you're going to do now is continue to break down numbers. 4 breaks down into 2 times 2. 3 is left over, doesn't break down anymore, it's a prime number. Now we look at the numbers at the end of our factor tree. Notice they're the same as the numbers at the end of the factor tree here. So we're still doing the same thing. We're looking for a pair. Pair of 2's means a 2 comes out. 3 that doesn't pair up has to stay inside the square root. So 2 times the square root of 3. Point of me doing that both ways is to show you that it does not matter how you break the number down. Doesn't matter what 2 factors you start with. As long as you keep going until there are no more ways to break that down, you'll end up with the same answer, right? Whether you took out 2 times 6 to make 12 or 3 times 4 to make 12. So don't worry about what numbers to choose to start. Just find anything that goes into this number under the square root and start simplifying. Okay? A couple more examples I'd like to do together. Square root of 50. All right? All right, and again, you may think of 2 times 25 right away. Or you may think of 5 times 10 right away. It doesn't make any difference. I'm going to do 5 times 10 this time, let's say. All right? Just keep breaking down. 5 doesn't break down anymore, it's prime. 10 breaks down into 2 times 5. So now look at the numbers that we have at the end of our factor tree. We have a pair of 5's. That means a 5 comes out. We have a leftover 2 that doesn't pair up. It stays inside the square root. So the square root of 50 reduces to 5 times the square root of 2. Square root of 54. A lot of ways to break that number down. 9 times 6, first thing that popped into my head. So I break that down into 9 and 6. Well, now I can break down 9. That's 3 times 3. And I can break down 6. That's 2 times 3. And now nothing else I can break down. So I look for pairs. I'm always looking for pairs to bring a number out. And here's a pair of 3s, so a 3 can come out. Now we have a leftover 3. It stays inside, all right, as does this 2. Both of these numbers stay inside of the square root. 3 of a kind doesn't mean anything. 3 of a kind means you've got a pair, so 1 3 comes out, this leftover 3 stays in, as does the leftover 2. The numbers that stay inside, you multiply those back together. So this is 3 times the square root of 6 at the end. Okay? Break everything down. Bring numbers that are paired out. Leave numbers that are not paired inside. Whatever you've got left over inside there, you multiply back together. So you just have one number under the square root. Right? And this is what we consider a simplified radical. It's still an irrational number, and both of these are. If you were to type square root of 54 in your calculator, you get a big long decimal that doesn't stop and doesn't repeat. It only stops because you run out of room on the calculator, but it goes on from there without a pattern. Same for the square root of 50, because they're irrational numbers. All right. Square root of 180, and if you're feeling like you understand what's going on, you can go ahead and try this one yourself. It's a slightly larger number, so I'm going to go through it with you as well. Pick any two numbers that go in there. I think with the 0 at the end, a lot of people notice right away, well, yeah, sure, it's going to be 10 times something. But I'm going to go small here. I'm going to say, well, I know that's an even number, so I know 2 comes out. And I know it's 2 times 90. And if you ever get stuck and you don't know where to get started, just take your calculator and start dividing by small numbers. Divide by 2, divide by 3, divide by 5. See if you can get the ball rolling until you notice some factors. All right, well, 90 is still even, so I know 2 would go into that 45 times. Okay, well now I notice 5 and a 9 and a 3 and a 3. And I think I've got all prime factors now. Again, you may have broken it up differently, but if you've broken everything down as much as you can, if you finish the factor tree, you should have a pair of 2s, a pair of 3s, and a 5 in some order. It doesn't matter what order you get them in. Just look for things that pair up. I've got a pair of 2s, so a 2 is going to come out. Now I've also got a pair of 3s, so the 3 is going to come out. We're going to multiply those together. So we have 6 on the outside. I've got a leftover 5, that stays in. Square root of 5. So the square root of 180 can be simplified, can be reduced down to 6 times the square root of 5. All right? That's considered a simplified, reduced answer. That's the kind of answer you're going to see in a multiple choice situation, whether it's in a course exam, an ACT, something like that. All right, so this process of breaking down square roots, we're going to see it come up a lot when we start solving more quadratics, when we look at a different kind of number starting tomorrow. I wanted to tie it back to what we were talking about before the quiz, though, and talk about how we would deal with it in this situation. Find the zeros of the equation, y equals x squared minus 45, okay? Hopefully we've mastered this idea by now. We find zeros or x-intercepts or solutions or roots by making y 0, and then we go to solve. Now, I would initially maybe try to break that down into factors. You might recognize it as one of those differences of squares deals. But 45 is not a perfect square. You know, so I can't really break down some number times itself to give me 45 if I'm dealing with rational numbers or if I'm dealing with integers. So the approach of trying to factor this one's not going to work out very well. What you're going to have to do is just get the x by itself, isolate the variable, add 45 to both sides. You get x squared is 45, and then you're going to take the square root of both sides. Don't forget, when you're solving an equation, when you take a square root to solve for x, remember 2 solutions. You need that plus or minus. So our answer here is going to be a positive or a negative. Now, rather than leave this the square root of 45, or rather than type square root of 45 in my calculator and spit out a decimal, it's not going to be quite accurate because I'm going to have to round it. I'm going to simplify this square root of 45. I'm going to break down the square root of 45 over here. Well, I know 3 goes into 45. 3 times 15 would work. I know 15 would break down into 5 times 3, and that's all I can do to break that down. You may have noticed 5 times 9 and done it differently, but we both ended up with a pair of 3s, which means a 3 comes out, and a leftover 5, which means a 5 stays in. Okay? So our answer here, the zeros of this equation, the solutions, the x-intercepts of this graph would be positive or negative, plus or minus 3 radical 5, 3 times the square root of 5. That's how we want to present our answer, right? In the simplest form possible, without dealing with the decimal approximation, without just leaving it as square root of 45. Okay? So that's how we simplify radicals. We'll practice that skill tomorrow, and then we'll apply that skill to an entirely new set of numbers that you've probably never seen before in tomorrow's video.